So color models are just colors in terms of numbers. That means we can convert from one model to another one. For example, we can convert RGB to CMYK. This is important because a printer, for example, need to convert a display image to CMYK first, then only it can use the CMYK model to print using the ink or the toner. So you can find formulas to convert from RGB to CMYK. This is one example of the web page that can do that. So since this course is introductory course to multimedia, you won't have to memorize this formula, but you need to understand them. And if, for example, in a test or exam, we require you to do some color conversion, we will give you the formula. But you need to understand how to use the formula. First, in RGB model, the value normally from 0 to 255, 8-bit number. This has to be normalized to 0 to 1. So this is how you do it. R prime is normalized of R, G prime is of G, and B prime is of B. And then take the maximum of these three and subtract it from 1, you get the black component. And this is the formula to get the CMY component. Examples of the calculation is here. For example, you see here, this is a cyan color, 0 to 55 to 55 or 00FFFF. You convert, you will get a pure cyan and so on. And the reverse conversion is of course possible. If you want the red component out of CMYK, this is a formula. It will involve cyan. Why cyan? Because cyan is the opposite of red in a color wheel. What is color wheel? Later we'll show you. It has something to do with hue. So if it's red, there will be a subtraction of cyan from 1. If we want the green component, there will be a subtraction of magenta from 1. Why? Because magenta and green are opposite to each other in the color wheel. And if blue, we subtract y from 1. So we will give you this formula if we require you to do some conversion in test or exam. These are the example of the calculation. You see, if we have a pure cyan here, we convert using the formula, we'll get the pure green and pure blue. Next, let us talk about hue, because the concept of hue is important because it is part of the two human interpretation based color model, the HSV and HSL, and also it involves the concept of color wheel. So what is hue? Hue is a measure of how close a given color to a primary or secondary RGB colors. Since there are 3 primary colors and 3 secondary colors between them, hue is best represented as angle on a wheel. Hue is related to the dominant or strongest component color in RGB model. White, black, and the grayscale between them have no concept of hue. For example, we put red. This is arbitrary, but normally by default, we put red at hue 0 degree over here, hue 0 degree, or 360 because 360 and 0 degree overlap at the same place, and yellow is 60 degree after that because the other two primary color of RGB, which is green, is at 120 and blue is at 240. so that the three primary color will be separated 120 degree from each other. And in between, for example, between green and red, what is the color we get by mixing green and red? We get yellow. So yellow is somewhere in between at 60 degree. Cyan is green at blue. We get cyan at 180. And magenta is mixture of red and blue. We put magenta at 300 degree between 360 and 240. So this is an example of color wheel, and this is the value of hue according to the color. Color with different brightness may have the same hue. For example, you may say that this is something like yellow, but not too yellow, is too much white in it. And this one looks like yellow also, but very brownish, or has a lot of black component in it. This one obviously looks like yellow. So as a matter of fact, you can do some calculation. You can go to this website, for example. You can get samples of colors with the same hue but different in brightness or blackness. And as a matter of fact, these three colors, even though they are different in the darkness and brightness, but they are all hue of yellow. Let us go to the website. This is a website. Let's say now I'm taking one of the color. This one is a green, and I want to take the same hue, meaning the same monochrome. I get this color. This is almost pure green, and this one is a green that is mixed maybe with some flavor of black. And of course, since color models are just number, hue can also be calculated. We need again to change the value of RGB to be normalized from 0 to 1, and then we find the minimum and maximum value between these three, and then we get the difference. And if red is the maximum value, the hue is then the difference between green and blue, the other two colors. So you see here, the difference can be negative, but if it is negative, we add 360 degree. And if green is the maximum, the hue is 2.0 add with the difference between blue and red. If blue is the maximum, the hue is 4.0 plus the difference between red and green divided by the difference between the maximum and minimum. So we get this value of hue not yet as degree. We multiply with 60, we get the value of hue in degrees. And if this subtraction is negative, we just add 360 to make it positive. Or you don't have to go through all this complicated calculation. You can launch an image editor, and then most likely you will find a tool in the image editor app where you can specify what hue you want, and then what are the color variant that you want from the same hue. For example, let me open Photoshop. How do we get color from Photoshop? For example, foreground color, we click here, set foreground color, click it, and then you get this pop-up window. This bar is actually hue, but it's not drawn in circular shape. But over here is 0 degree, 60, 120, 180, 240, 300, and 360. So you can change the hue, and then after that you can choose any of this color that has the same hue. So if you change the hue, you can see only the value of hue change here, and then when you choose the colors that are having the same hue, the other value will change except the hue. So this is how you get different colors with the same hue. And this page is showing you what we did just now. Next, let us officially talk about the concept of primary colors. The concept of primary color depends on the model used. Only RGB and CMYK have primary colors. RGB primaries are red, green, and blue, and because of that, yellow, magenta, and cyan are secondaries. For CMYK, cyan, magenta, and yellow are the primaries. So black is not primary actually, and the secondaries are of course red, green, and blue.